Hey everyone. Okay, I'm going to go through the inequalities slides here. I know it's been a while since you've probably looked at these, but I'm going to go through and do the questions with you. So we're going to start with the first one. Question 1. Truck hauling bags of grass seed weighs 3,900 pounds when it's empty. Each bag of seed it carries weighs 4.2 pounds, and the equation for the gross weight, W, of pounds, is given by this equation. W is equal to 3,900 plus 4.2 times B for B bags of grass seed. And so remember, W is counting the total gross weight of the truck, and B is counting the number of bags of grass seed. This was a story that was in earlier lessons as well. So question A, the state highways have an 18,000 pound gross weight limit, okay, which means that the truck cannot be more than 18,000 pounds, probably because it might tear up the road and things like that. Trucks are pretty heavy and they can damage the road as they drive along them. How many bags of grass seed can the truck haul? Set up and solve an appropriate inequality. All right, and so in the first box here we want to type our number sentence, our inequality. Well, we start with our equation, and since they have a limit of 18,000 pounds, that is the most that the truck can weigh. So we can set up an inequality, and we can do it a couple different ways here. Let's do it the first way here. We're going to set it up as saying, I'm going to start with the 3,900 pounds for the truck itself, plus the 4.2 pounds for each bag of seed. That has to be less than, but it could also be equal to, the 18,000 pounds. Right? So that is one way to write that. Another way is if you start with the 18,000, we could say it's 18,000, okay? And no matter what, it cannot be bigger than that. So we'd have to be less than or equal to that 18,000. And then we just put the rest of the equation. 3,900 pounds for the truck plus 4 2/10 pounds for each bag, and we can have our amount that way. The solution would be, well, how many bags can the truck haul? All right. Well, the bags cannot be more than a certain amount. So that means the bags must be less than or equal to some amount there. Now, how much is that amount? Well, let's take a look. Let's take a look at our number sentence. Either one will work. And if we solve it just like we did with equations, we can actually get the number that would correspond to our result over here. So I'm going to just quickly go to the calculator here. Okay. And if we start with our problem solving skills like we've learned about. We start with our 18,000. We subtract off the beginning weight of the truck. That leaves 14,100 pounds possible for the bags of seed. Divide by 4.2 for each one, and we get 3,357.1428, and so on. That means that the number of bags must be less than, what was that number again there? 3,357.12, and so on bags. Well, you can't really have 0.14 of a bag. The truck's either carrying whole bags or it's not carrying bags at all. Since each bag weighs the same amount, we can assume that it's not carrying partial bags. So that means that the number of bags must be 3,357 bags or less. It could carry less than that, but it can't carry more. It can't. If you throw one more bag on that truck, 3,358 bags, that would be too much, and the truck would be over the 18,000 pound limit. All right, we go to the next slide, and we just need to record our answer in there. So 3,357. We'll round it off because that's what it is. That's the number of bags. All right. Then, next question is, make a graph of your inequality using Desmos. Make a new blank graph, add the inequality and the ordered pair for our solution from the table from the previous lessons. So from here, we need to put in our table. We need to put in our ordered pair. We need to put in our inequality as well. So we go to Desmos, open that up, start a new blank graph, and we can just take our inequality, 18,000, and it has to be less than or equal to that amount. Notice the sign changes there. 3,900 plus 4.2 times the number of bags. And it says to add a slider there, but we really don't need to. Okay. And in fact, I think what they want us to do here is we may have to use an X. There we go. We may have to use an X to describe that. Let's see. We've got to zoom up pretty far because we've got a lot of stuff here. If we go right there. There we go. There is our inequality right there. Notice that it stops right there. Okay. And if you think about that, think about what is that number that's right there. That is our 3,357 bags right there. That is our amount. All right, let's put in a table. We're going to go to the plus, put in a table, and then we are going to copy down information from our table right here. We're going to start with 0 and 3,900, and then 1,000 is 8,100, 1,100, 2,000 is 12,300, 2,000 bags, 12,300. Okay. And then 3,357 is 18,000. All right. And then, if we zoom out, we should see, there we go, there is our line. We can even adjust it if we need to. But there we go. There's a graph. And then what I would need you to do is save it. We just save it. It'll give us an address. We take that address, we're going to copy it, go back to our document, we're going to paste that link in here. That's what we're going to do for that. All right. Question C here. Looking at your graph, how do you know if your answer to part B makes sense? Well, if we go back to our graph, how do we know if the answer makes sense? Well, if we take a look at our points here, and if we connect them with a line, we can see that they all land on a straight line, which means it's a constant rate of change. And that constant rate of change is that 4.2 pounds. That 4.2 pounds for each bag. Every time you're adding another bag, that represents that rate of change. And so the 3,357 bags lines right up along that same thing there. All right, and then we can type that response into your box there. All right, let's move on to the orange slides. Anthony and Christina are trying to decide where to hold their wedding. Oh, and we got Anthony and Christina again. They have several choices now. They only have a budget of $8,000 they can spend, so they got to limit what they can do. On this slide here, we need to write the 4 different equations for the 4 different venues where they can hold their wedding. Right? And then, depending on the solution, will determine the number of guests that they can invite based on their budget of $8,000. So, the Metropolitan Club costs $13,000 plus $1,300 plus $92 per person. So let's say we're using G as the number of guests, or you could use P for people, whatever. So they have a budget of $8,000. They can't spend more than $8,000. So that means that the $1,300 plus the $92 per person has to equal $8,000. It could be less too. We could write an inequality. There's a way you could write an inequality for that as well. But that is the equation. They need the number of guests to equal $8,000. Black Elk Park, same thing. $8,000 is equal to $500 for the rental plus $65 per guest. The Dabbling Duck, again, $1,000, $1,400 to rent the place, plus $80 per guest. And Pranzo Ristorante, again, $8,000 is equal to $300 rental fee. That's not too bad. Plus $145 per guest. And then for each one, we're going to solve and figure out, well, how many guests could they invite if they chose each place? How many guests could they invite? Well, let's go through the steps. Same thing just like before. Okay. We're going to start with our 8,000, subtract off the rental fee, and divide by how much it costs per guest. And so for the Metropolitan Club, they can't have 73, but they can have 72 guests. Now, so we can't quite have 73. 73 would put them over their budget. Repeat that for the other ones. 8,000 minus 500, which is 7,500, divided by 65. Ooh, they can get 115 guests there. They can have 115. Quite a bit more. Might be a better deal for them. 8,000 minus 1,400 divided by $80 per guest. 82 and a half guests. Well, you can't really have a half of a guest, so they can only invite 82 people. And finally, $8,000 minus 300 gives us $7,700 divided by $145 per person equals 53 guests only. 53 guests only. And that is as much as they could do. Seems like, oh, only $300, but because it costs $145, they can't invite any more than 53 people. All right, and I'll pause there, and I'll continue the next part in the next video.